All right. Welcome, everyone, and thank you for visiting with us today. Today, we are going to talk about visibility without borders and using NETSCOUT to help migrate applications to AWS. My name is Michael Segal. I'm Area Vice President of Strategic Alliances, working very closely with AWS on some of marketplace, go-to-market activities as an advanced technology partner for AWS. We are making sure that we are in alignment in terms of our technology initiatives. And if you happen to heard this week about the Amazon VPC ingress routing announcement in which NETSCOUT was featured, this is one of these examples of how we collaborate on our technology initiatives.
Thanks, Michael. And I'm Ray Krug, Solutions Architect for NETSCOUT, and I kind of get the fun job. I get to play with all this technology, so that's kind of cool. And for example, the VPC ingress routing and the VPC traffic mirroring, when they launched that in June, I was working with our engineering team to make sure that our technology could cope and could help you get visibility in your environments using that technology. So it's been a lot of fun. The other angle of fun that I get is I get to help our customers implement visibility solutions into their environments, whether they be all in Amazon Web Services or whether they be on-prem or a hybrid solution, and help them architect visibility solutions into their environments. So it's all good.
Great. So this is our agenda for today. We are going to kick it off with describing the different challenges associated with visibility into the hybrid cloud. As the hybrid cloud expands across different geographies, expands across data center, colos, the cloud, and workloads are moving around, visibility becomes a big challenge, so we're going to address some of those challenges.
And I'm going to talk a little bit about the new approach that we have for continuous monitoring in the hybrid cloud and give you some migration use cases to show how visibility can help you migrate with success.
And then we'll listen to our customers. So we've just finished a survey of our customers, and we'll share with you some of their views in terms of what we are talking today about visibility without borders. So if you're not familiar with NETSCOUT, NETSCOUT is assuring service performance and security for the largest enterprises and service providers in the world. And we're doing it through what we call visibility without borders. And by doing that, we are solving the toughest problems for the largest IP networks in the world. You can see some of our customers here in different verticals for the enterprise and service provider segment. So we'll start with digital transformation. The digital transformation changes everything. Why? Because digital transformation is using digital services and data analytics to create business and competitive differentiation. Therefore, what it means for information technology, IT organization, and the CIO is that they become much more relevant to the business success of the enterprise. And as such, the IT organizations also need to transform themselves to align with the digital transformation initiatives at the business level. And few examples of this IT transformation.
Well, a great one, of course, is data center transformation as far as IT is concerned in this context. At the end of the day, you start with your data center on-prem and you migrate it to the cloud or to a colo. And what we're seeing is hybrid is just everywhere. And that's a blend of legacy technologies and on-prem and cloud technologies and virtualizations all over the place. And of course, with the public cloud, you've got a whole new bunch of technologies to play with. I love to play with them anyway, like PaaS, IaaS, and of course, serverless technologies like Lambda. There's a lot of components that you can start to play with to actually create your new solutions in that next generations of data centers. That's kind of part of that data center transformation initiative. And then you've got a choice. And you've got a choice not only of components where you can deploy your applications, but how you do this. So lift shift your applications as is and push them all into the cloud or wherever you want to put them in, or of course refactor them. And of course applications are evolving all the time, as you quite rightly have seen. If you've gone to any of these keynotes, refactoring is kind of something that's really on top of mind at the moment. But of course, Refactoring means kind of rewriting what you've got or creating new stuff into microservices, adding lots of more components in these new technologies, lots of dependencies, and potentially still dependencies on the on-prem stuff. So remember, I talked about hybrid. Sometimes you don't migrate everything to the cloud and refactor everything. Sometimes they need to communicate back to on-prem services, Active Directory, databases, and things that you're, let's say, not ready to migrate at the moment. So when it comes to visibility and refactored applications, DevOps, they'll stick a lot of performance monitoring within their code. But of course, when it comes to deploying applications into production, there's a lot of other things going on. That's the shared services that could cause disruption to the end user experience at the end.
Right. And in this environment in which you have legacy equipment and legacy infrastructure, and now you have workloads that migrate to the cloud, across geographically dispersed hybrid networks, what is happening is that you have a fragmented visibility. And by fragmented visibility, what we mean is that you have visibility into specific domains, but you don't understand how they interoperate together to deliver service to customers. It's the equivalent of not seeing the forest for the trees, and we'll talk about the complexity associated with the new IT transformation technologies and services, and why visibility is becoming so important to make sure that you execute on IT transformation plans in spite of this complexity. And indeed, a recent survey by ESG confirms that most of the IT organizations agree that the complexity is growing over time, and they need to deal with this complexity very effectively. Ray, would you demonstrate the complexity and the visibility requirements associated for workload migration?
Yeah, I mean, the visibility challenges of the refactors applications is like, let's say you start with your, maybe it's monolithic, maybe it's a microservice-based application, but it's at least in one place. It's in your data center or your multiple data centers. You've got presentation, application, database, and the shared services layer. And then you start, okay, let's first migrate my presentation layer up into the cloud. Okay, that sounds a cool idea because I can scale that very easily. I can be agile. I can take advantages of the efficiencies that the cloud brings to me. So that's now starting to move things around. Next, I want to kind of refactor or develop my application, spread it out a little bit into the useful technologies that I have with the public cloud, or even take advantage of that as a stepping stone to migrate things away from my data center and start putting in maybe in a co-location. So I've got my application layer now spread out. Next, I'm confident to migrate some of my database technology into the cloud to make my applications more optimized, get that data closer to where my processing is being done. That's the next layer. And of course, you can see what's going on there. Now things are spread out. You've got the different domains, the different architectures that now your application is layered over and is communicating across. You're getting the back-end authentication back to your data center. You're doing localized database access and potentially remote across Direct Connect or whatever it might be down into your centralized database in your on-prem data center. So that kind of creates a visibility challenge, those different borders. It's more complex architecture, more components to deal with. And at the end of the day, you've got to make sure that your application performs at least as good as it did before your migration, before your strategy, to actually create this agility and this ability to service your business much better. Lots of dependencies there, as you can see. And when it comes to troubleshooting this thing, users now complain, oh, things are slow today. Okay, where do you look? How do you know which domain, whether it's a DevOps dashboard that you're using, a NetOps dashboard that you're doing, or taking a look at the specific application performance things? Everybody's saying, oh, all lights are green, but there's still a problem. So having some holistic visibility over all that will actually get you to that root cause much quicker. So that's kind of what we're all about. The other thing as well is, of course, asset tracking, okay? I've got more components than I had at the beginning, that's fine. And the cloud gives you the ability to be very agile and spin up new applications and services, new subscriptions to AWS, new lines of businesses doing their shadow IT and creating a whole bunch of new services which are integrated into this whole complexity. So how do you track what's going on there without the visibility across those borders as well? And then one final thing, security, cyber threats. Now you've got 3 different domains, at least, that you need to try and explore to actually find if somebody is infiltrated into your network, or somebody is trying to attack these servers from the outside. So it's pretty much a bit of a problem to get that sort of visibility. So what's needed, of course, is a new approach to this continuous monitoring in this hybrid infrastructure to actually get you that visibility you need to be successful, to migrate to the cloud successfully. So, Michael, what is this new approach?
Okay, so let's take a look at this new approach. And as you can see, all of a sudden, this complexity is being converted into what we refer to as a dependency map. You see here, very effectively, all the dependencies across all the different components in this hybrid environment, including public network, on-premises, and colos. You see this in the context of service. And there's a big difference between service and application. Application is one component of the service delivery foundation. So if you think of a service, right, it's an application that is using a network. It's using service enablers such as authentication, authorization. It uses domain name servers. It uses databases. So there are multiple components to a server. And holistic view is not just about geography end-to-end, but it's also across the entire stack, right? So you need to see all the different layers, from layer 2, from the data link to the network, to the transport, the session, the application layer. And indeed, as we will demonstrate, by looking at NETSCOUT Smart Data, we can see across all these layers, heuristically identify any application and understand the error codes associated with this application and then tie everything together. So we understand all the dependencies. We see it everything from layer 2 through layer 7. And then we'll also demonstrate how we convert this visibility into actionable intelligence. What does it mean, actionable intelligence? We said we are doing service performance and security assurance. So actionable intelligence means that within a few clicks of a mouse, you can really understand where's the root cause of your issues, be they performance or security issues. For both real-time and forensic, we also store the data as in compressed format, so we can do forensic analysis and back-in-time analysis by referring to this data. And the bottom line is that we reduce the mean time to knowledge and mean time to repair by over 80%. So all this is referred to smart visibility because many companies talk about different types of visibility. We refer to it as smart visibility, and it is based on smart data. But what exactly is smart data, Roy?
Okay, yes, I thought you were going to ask me that question. Well, basically, smart data starts life as packet data. Packet data is the thing that applications communicate with each other, TCP/IP. It's everywhere, whether it's on your on-prem, in your colo, or in your cloud. It's fundamental to the way applications communicate. And what we can do with that is convert that packet data, which is ultra high definition, giving you the detail of every interaction with anything that goes on with the network, and translate that into smart data. And I'll talk a little bit about some of the metrics and what we do with that smart data in a minute. But the first thing, of course, is how do we acquire that packet data in order to generate the smart data? Well, there's kind of a bunch of different mechanisms that we have. So I'm starting with the data center here. You may have VMware, ESX, you may have NSX, and we have technology that embeds into the NSX hypervisors to actually extract the packets directly from the hypervisor into our technology to create the smart data. If you don't have NSX, you have other technology like port mirroring, spanning, and tapping that you can do within the network in the physical world of your data center environment or your colo environment.
And the VPC ingress routing that was announced today, that's yet another mechanism for us to acquire?
Absolutely, yeah. So Amazon, we've got a couple of mechanisms. The first mechanism, of course, is the VPC traffic mirroring, which allows us to mirror traffic from ENIs on instances inside Amazon and mirror them to targets. So that's one option that we can do. The other one, of course, is with that VPC ingress routing. We have got the ability to, obviously, that allows you to transit your traffic coming in, let's say, from the internet to your firewall or applications, and we can mirror off that traffic that's coming into your Amazon environment and acquire the traffic that way as well. So there's a couple of ways in the Amazon world. And then, of course, if you don't want to use VPC traffic mirroring for whatever reason, we have other cloud-native technology that we can install into VMs themselves, into containers, and into pods. So we work within a Kubernetes cluster, acquiring that packet data, and then with that packet data, what we do is translate that. We convert that to the smart data. We have patented technology. It's called ASI, Adaptive Service Intelligence, which converts those packets into key performance metrics and security metrics. More of that in a second. And our technology that does it is called vStream, Virtual Infinite Stream. So that technology is software and deploys into the cloud, and is the target for those mirrored packets, effectively doing that conversion into smart data. Then, of course, once it's smart data, you put it into analytics platforms. We have our own. It's called InGenius-1, which gives you the workflows to actually troubleshoot, do service triage, and do reporting. Again, we'll talk about that in a minute. But, of course, you might want to take that smart data and push that into your own data lake. So we have the ability to put that onto a Kafka bus, get that then to be consumed by any consumer that you want to do, and deploy it into your own data lakes. Again, whatever that might be, Redshift, S3, you name it. So in terms of smart data and the metrics, remember, packet data is ultra high definition, and we store the packets as well within vStream. So we don't throw away that ultra high definition information, but what we do in real time, we assess that for our smart metrics. So we've got packet data, session data, and those smart metrics, those key performance metrics. A couple of examples that we have here is things like response time. So the response time is interesting because we can distinguish between application response time, i.e. how quickly those servers are responding to those application requests, but also the network time, the network delay. So if you've got those two metrics, then you get a sense for, is the problem to do with the transit of the network, or is the problem to do with that EC2 instance sitting in the cloud, or that virtual machine sitting in NSX? So we've got that ability to distinguish the two. And remember, we've got a hybrid environment here. So if you've got your database sitting on-prem, let's say, and your app service sitting in AWS, you're going to expect a bit of extra transit time rather than what's going on if they're both locally in the same VPC. So our ability to distinguish between the two gives you the information you need to say, hey, it's that EC2 instance that's the problem, or oh, it's the transit, that's the direct connect that's the problem, or it's the server that's sitting in your NSX or your data center that's causing the problem. So that's pretty important that we can do, and we can get that all from our packet data and the smart data there. So application, network response time. We can also do some more detailed forensics, deep packet inspection, the error messages. So whether that be HTTP error messages for your REST APIs, 501 errors, or whatever it is for your GET, POST, or PUTs. We can do the same thing for database technology, selects, inserts, take a look at the error messages per database, per request type, and it goes on because we support a huge amount of applications protocols just by virtue of the fact that the TCP traffic is running over the network. Thirdly, security metrics. We can take the advantage of the fact that we've got that ultra high definition packet information and use it for security insights. A couple of examples there, things like weak ciphers in your certificates, using SSL instead of maybe TLS as a good example. Self-signed certificates, bad practice. Nearly expiring or expired certificates. We can see that all by looking at that wire data, giving you that indication that things aren't quite right in your infrastructure. Threats, we can take a look at those, see those attacks trying to slow down or break your EC2 servers. We can see those and tell you that that's going on. And of course, a bunch of behavioral analysis, because don't forget, we've got access to all the conversations going on in your environment, whether that be in the cloud or on-prem. So we can actually take a look at what's going on. So all of that makes it smart. What can you do with smart data? Well, smarter analytics, and our platforms here gives you the various workflows and user interfaces to give you a common situational awareness for application performance, network performance, security performance, things like dashboarding, things like drilling down from your dashboards to your service monitors for your applications, dependency mapping to actually see how your application's communicating, what the dependencies are, asset tracking, and obviously performance tracking as well. discovery. We're seeing everything that's on the network. So you don't have to tell us that those EC2 instances are there, those app servers are there. We discover that based on the fact that they're communicating with something else. So we see what's going on. And often it's a surprise when some servers are on our dependency map that our customers, our users have said, we decommissioned those a couple of weeks ago. No, they didn't, because they're still communicating right now, today, and it's sometimes a surprise. So we've got reporting galore, we've got alerting galore, we've got machine learning, threshold alerts, baselining alerts, so you don't have to specify the thresholds. And also, as I said, the machine learning root cause analysis, let's say service slowing down because it's got an increased number of transactions. That's what we tell you about, not just all these alerts and dashboards as well. Security perspective, certificates and security analysis, as I've described. We've got workflows to help you detect that that's going on in your network, those poor practices in there. And at the end, you'll see packet forensics there. So again, we don't throw away those packets. They're there. They're there, and if you think about it, we use those to calculate our metrics, but we use the metrics to actually figure out what was going on. So you use the metrics, you don't have to sift through gigabytes of packet data to get to these workflows. And we'll show you that in a minute as well. So that's our common situational awareness.
Okay, thank you, Ray. So why don't we move to a use case? And as I mentioned before, NETSCOUT is doing service performance and security assurance. So let's first take a look at service performance, right? So this is service triage of understanding the root cause of issues and looking at the workflow of accomplishing this by monitoring hybrid environment. And in order to accomplish this, what we will look at is the overall architecture first. So we mentioned that we have full alignment in terms of technology with AWS architecture. So we mentioned mechanisms such as traffic mirroring, such as VPC ingress routing. There is transit gateway. So we implement all these technologies as part of our global hybrid cloud architecture. And Ray, why don't you talk a little bit about our architecture here?
Oh yeah, because this is like, as a solution architect, this is where I start to get excited about some of this technology and the features that I can use to actually give me that visibility in the AWS infrastructure. So starting on the left there, we've got things like components in the marketplace. So one of the things our technology, our Ingenious One technology and our vStream technology I talked about earlier is in the marketplace. So it's 2 or 3 clicks using CloudFormation templates to actually deploy this into our infrastructure. One best practice might be to stick this into a management VPC. So stick our management application and the collector, the vStream, into that management VPC and connect it to the data sources. Remember the VPC traffic mirroring through VPC peering or a transit gateway to connect and interconnect VPCs together. So I think Amazon launched sort of interregional transit gateways during this show here, so you can even do that cross-regional. And the perspective of that is we need to acquire the packets. So if we've got a transit gateway in there, then our EC2 instance, which sits in our workload VPCs, there may be one, there may be many of those, we can actually mirror the traffic from those EC2 instances, send them across to the vStream that's sitting in the management VPC. So it's a very efficient way of doing things. Other things that we can do in this technology is using the NLB so that we can have multiple vStream interfaces being fed by an NLB to cope with scaling the amount of traffic. So there's a number of different ideas for best practices depending on the amount of traffic that you're sending across the network, but we cope with it all. The other angle, of course, as Michael was talking about, VPC ingress routing. So those workload VPCs may or may not, which is more often the case, have an internet gateway. There may be a separate VPC with that internet gateway. Okay, that's fine. So that goes then with VPC ingress routing, you can actually direct the traffic to your firewall or your infrastructure that, to save you natting across, you can use it directly to a firewall which has potentially 2 interfaces, an external interface and an internal one going back to your VPC. So what we can use is VPC traffic mirroring on those ENIs in combination with that VPC ingress routing, and we can see external traffic and internal traffic. We can do a lot with that, as you'll see through some of the presentations. Finally, of course, right at the bottom, I've got the transit gateway connecting to the direct connect down to my colo or down to my data center. So again, we can, in those environments, we can deploy, sure, we can deploy vStream into that virtual environment, the colo or data center. We've also got physical devices as well. If you've got servers that's sitting on physical networks, you might want to have physical servers in there. So a bunch of interesting technology that provides you that visibility across those borders. Here's it simplified, okay? In terms of seeing vStream here in our data center on the right there, vStream again in our colo, seeing what's coming in and out of the colo. Maybe that's my access point into my Amazon Web Services environment. And then in Amazon, I've got vStream again. It's the same technology. We're looking at packets, so that, of course, that's why vStream sits everywhere and sees everything in all those domains. So, of course, with that, what are our migration best practices?
Yeah, so best practices start with before migration, getting ready for the migration, right? So what do we do before migration? First, we need to identify the right workloads to migrate. If the workload is not performing well on-prem, probably not a good candidate for migration. So you need to really understand the performance of your application, network, everything we discussed, understand the dependencies, and oh, by the way, if you have an application, the dependencies are very poorly documented. That was traditionally the case. Now that we are moving to microservices, the situation exacerbated by the fact that there's an agile development and so many things happening. So you cannot possibly document everything. So you need some kind of automated mechanism to understand all the dependencies. Then you establish performance baseline. So I think the expectation is once you start the migration and you migrate something to the cloud, you'll get either equal or better performance in the cloud because you can elastically scale up and down as the needs require, so you would expect the performance to be better. But you need to capture the baselines to be able to compare in the future your performance to existing situation. And then develop migration strategies. So some applications that perform well and you think that you are satisfied with the performance, you can just lift and shift. If you have enough network throughput and you have well-architected design, most likely it will operate well. Some others, you may decide, they're more mission critical, more delay sensitive, so you may want to refactor and work on a new architecture instead of monolithic architectures, create more agile and microservices-based architecture. Then once you start the migration, again, you need the visibility to assure that the services perform and the user are not impacted, right? So the user experience should be consistently good across the entire process of this workload migration. And then after migration, continuously monitoring the new hybrid environment, which is extended, it's more complex, but if you have the right visibility, then you can really understand the availability, the user experience, and also understand vulnerabilities and security threats, which we will discuss a little bit later. So Ray, can you give a few examples of this visibility in action now?
Yeah, sure. And I kind of hinted it at the previous architecture slide. And here I've got an example of data center and migrated or components of the application migrated into AWS. You can see, of course, vStreams in both those domains. So we have that holistic visibility in both those environments. And now, of course, when you've got users complaining about performance, we can understand what's going on, whether the database is slow in the AWS, whatever that technology might be, whether the app server is slow, whether the web server is slow at that point. Of course, if it's backhauling traffic to your data center, again, we've got vStream there monitoring that application performance or that database performance by virtue of that traffic transiting the two networks. So we've got that covered in those sort of environments. And of course, just adding the colo here, depending on your architecture, you may be using it as the transit to your cloud services. So now we've got the ability to see at what point your application's slow or causing problems. Again, when it comes to, hey, the users are saying it's slow today, or I can't log in, or I've got errors, we can actually help you pinpoint where in that complexity, sophistication, or whatever you want to call it, the issues are. The other aspect, of course, is this visibility without borders. The idea of saying, here's my application that I've migrated into those aspects, and here's our service dependency. And now what we've done is actually demonstrated the fact that We've got visibility in all those domains. We're seeing how those applications are communicating across those domains and within those domains using that vStream technology. And we show you how it's built up, how the application's built up. So when it comes to solving performance problems, we know which particular type of link is actually causing the issue. But that's all very well, right? So it's all very well that we've got instrumentation, we've got visibility of how the application's architected and the assets. But how does that help you with a workflow that makes it really simple to troubleshoot problems within that environment? And I think, Michael, you're going to talk a little bit about that.
Yes. So quick and effective service triage. So within 3 clicks of a mouse, with this top-down approach, you can really understand the root cause. And obviously, you have the instrumentation in place, as Ray mentioned. Everything is set. You generate smart data. Now, we use another platform, which is called IngeniousOne, to convert this intelligence into actionable intelligence. So we create workflows. It starts with the service dashboard. So with the services dashboard, you can see any service based on domain, based on technology, based on geography, based on function. You can customize the domains any way you want and also identify the different attributes or KPIs that are being monitored. And then, in this context, you will see from the bird's eye view, oh, I have a problem with this specific domain, so let me drill in. So the next drill in is the performance analysis, and it's called Service Monitor. And this Service Monitor gives you the ability to look at load, latency, and errors, as I mentioned before, because we heuristically identify all the applications. We understand the errors in context of load and latency, so we can map everything and see if there's a correlation between them. The problem is with this specific session. And then we go to session analysis and segment by segment analyze all the transactions. And at that point in time, we really see where the problem is. If a client communicates with the server, and then a server communicates with the database, and we see that there are errors there, we know exactly where the problem is, but we can actually go deep dive into the packet analysis because we do store it, and then we will see the packets that are only relevant for our analysis, because even though we capture all packets, we do not have to sift through millions of packets. We immediately look at the packets that are associated with a specific failure. So that's our top-down effective service triage workflow. And the other aspect of this, I mentioned before that in order to support digital transformation, IT transformation needs to happen. And for IT transformation, there is a technology transformation that we discussed. And then there is also organizational transformation. So the organization needs to be more agile. They need to collaborate more effectively. And what you see here is how common situational awareness becoming the tool that helps them to collaborate, create feedback loops. So now they kind of see NetOps, DevOps, SecOps, or any other organization can see their domain, but they also see the dependencies on other domains. So they see if the problem is within their domain or another domain. They can very quickly identify the root cause, and it really gives them the ability to collaborate effectively and avoid finger pointing, because in many cases, the finger pointing starts when everybody thinks that someone else is at fault. Here, you can really drill down very quickly and understand the root cause. So would you like to do that, Ray, to drill down into one of these domains next?
Yeah, we'll pick DevOps from the perspective of, hey, we've got this application that's now deployed into this infrastructure. It's a microservices-based application. And now each tile doesn't represent a physical domain. It represents an application domain, a layer of that application. So we're seeing here things like external HTTP, and application layer, database layer, Active Directory, so that's authentication layers, DNS layers. We're seeing all those layers, and we're highlighting metrics associated with the performance of any and each of those layers. And from there, we can actually drill down and pick a layer based on some of the metrics that we're showing here. In this case, I'm going to look at the database layer, etc. Drill down into that performance layer of all the services that are doing that database activity. So that might be my MySQL servers in this instance. I may have multiple of them. Some may be on-prem, some may be in colo, some may be, of course, in AWS. And I can pick any one of those servers and see one that's degraded degraded, or it's alerting to me one that's degrading, and I can drill down into those performance metrics. Remember, I said there were performance metrics around network and application performance, and distinguishing between that allows me to optimize my application because it may be long-haul transit to the app server being in one domain and the database server somewhere else. We'll have the evidence associated with that. And then, of course, we'll have the drill down to not only the application performance, but the errors, the drill down to the sessions. So this now goes to the individual conversations, for want of a better word, between app server and, in this case, database server. We're seeing errors, and then you can finally drill down into the last area, which is the packets. And the packets kind of, well, when we look at those, it's kind of interesting. You can't read it at the moment, but in terms of MySQL, we're actually telling you the select statement. We're telling you the select error that was caused. In this case, it's bad code and somebody selected the wrong database. But okay, that doesn't matter. But the point is, we can do this workflow down to the packets. But really, we told you that this problem was going on the second screen. You don't need to go down to the packets to prove that there's a problem there. And that's kind of the important thing. This is sort of the backup evidence that now I can go to DevOps. I don't know who in DevOps here, and say, look, this is something that your application is doing, and here's the proof that it's doing that. Or I could go to NetOps and say, hey, we need to optimize this location of this server because it's too far away from the application server. So it gives me that ability to figure out what's going on and optimize the service.
Great. Thank you, Ray. So now let's move on to the second use case. I mentioned basically NETSCOUT does two things: performance management and security management. So let's look at the security management and how risk mitigation and cybersecurity and threats is enabled with NETSCOUT Smart Data. So here I want to introduce to you yet another component of Smart Data. So far, we discussed the Smart Data in the context of looking at IP packets or traffic flows, aka wire data, and gleaning all the information layer 2 through 7 end-to-end and analyzing this to create key performance indicators for both security and performance. Now I introduce another component of Smart Data, and it's called Atlas Information Feed. And this is based on analysis of a large group of NETSCOUT cybersecurity experts of 1/3 of the global internet traffic. We have relationships with many of the largest service providers in the world to access the traffic and analyze the traffic to identify indicators of compromise in this traffic. So with these indicators of compromise, such as malware, command and control, remote access Trojans, and others, we can identify them as they traverse the network even before they reach the enterprises. So with this platform, we identify them very effectively once they reach the enterprise and be able to deal with them in a timely fashion. We also can import third-party IOC indicators of compromised databases based on standards such as STIX and TAXI. And next, what we do is looking at vulnerabilities. So Ray addressed some of those vulnerabilities, right? If we have like weak ciphers, such as SSL version 2, if we have X509 certificates that are not signed properly with a short key, or the key are expired, or self-signed certificate, if you have other weak ciphers such as MD5, C4, or others. So we can identify all this because we see all the traffic data. And last but not least, we look at threat indicators. So we look at volumetric attacks, such as ICMP attacks that can be hundreds of gigabytes in throughput, up to a terabyte in throughput. We identify state exhaustion attacks, such as TCP sync attacks, and application layer attacks, such as HTTP flooding attacks. And what you see on the top right-hand side is Cyber Threat Horizon, which is a real-time representation of all these attacks at any given time worldwide. And the color coding is related to the throughput of the attack. Yellow is medium size, red is really high volume attacks. And then what you see at the bottom on the right-hand side is basically the dashboard for our threat analytics. And Ray, would you demonstrate the workflow of how we use threat analytics to identify problems?
Sure, and of course you'll be familiar with this. It's like kind of a dashboard, and this time our dashboard is taking our IOCs, our indicators of compromise, and showing us which ones are going on in the network right now or historically as well. So we can pick one, we can pick that rat, the remote access Trojan, drill down into that, and then get a sense for, okay, what host was affected by that, what client, and what was it doing? So of course it might be being, say, attacked or being part of that process, and we can actually see what it's branching out to, what it's trying to perhaps infect or communicate with. And then of course we can drill down further, looking at what that is then starting to communicate with, potentially figuring out, okay, it's either infecting something else or it's trying to send out traffic out to some sort of exfiltration concept. And finally, of course, we've got the drill down to the packets, because remember, they're still there, they're still sitting on that vStream, and we can drill down to provide that forensic evidence to actually see what's going on and the actual detail about what is being exfiltrated or the access that's being done. So that's very useful for our next thing I wanted to talk about, which is our SIEM integration. It's bidirectional. So firstly, of course, we alert on what we're seeing in terms of the threats that are inside your infrastructure. Remember, that infrastructure could be in EC2, could be in your colo, could be on-prem. We're borderless, agnostic, as it were. So we can send those alerts to SIEMs that you already do, and it's already processing a whole bunch of other threats, but may not be the ones that we're looking at because we're looking at the packet data to do that. So that's one angle. And then from that SIEM, once it gets that alert, we've got that drill down back to the forensic packets that I was talking about earlier on. The other thing, of course, these SIEMs are doing all sorts of other things, using logs perhaps to detect some attacks and some threats and servers that are going wrong in the infrastructure. But where they struggle is the fact that they don't have access to that packet data, because that's where we come in, because the vStream has the packet access. So from that SIEM, you can say this IP address and just drill down straight to the packets into our infrastructure, and it'll give you the packets relating to the conversations that are going on for that particular host. And you can do some packet-based analysis to see what's going on. So it becomes a really powerful thing that can augment what your SIEM already does today.
Thank you, Ray. So the last section of our presentation today is the voice of NETSCOUT customers. As I've mentioned before, we recently finished a survey of our customers, and I want to share some of the insights with you. Now, this next slide is very busy, so I realize it's too busy, but the takeaways are very simple. There are three main takeaways. The first one is on the right-hand side. You see the Net Promoter Score. So you see that the NETSCOUT Net Promoter Score is so much higher than the industry average. And this is a clear indicator, and this is based on Tech Validate's results, and they keep track of all these different statistics. And what they told us is that they were actually amazed with the level of customer loyalty. So this is a clear indication that NETSCOUT is very strategic to our customers, and we have long-term relationship with them. The second takeaway is we talked a lot about the importance of user experience. So 98%, basically all of them, agree that NETSCOUT helps improve user experience. And the third one is we are here talking about application migration to AWS. So they all agree that NETSCOUT helps accelerate migration to AWS and cloud migration in general. So we talked a lot about visibility without borders, about smart visibility. So we asked our customers, is it really important to you? Is visibility really important to you? Or in other words, would you agree that what you can see can hurt you? And the resounding answer is yes. So obviously, these are customers that realize the importance of visibility. We have been working with them. But still, it's still a valid question, and they definitely validated it. And then we asked, OK, so if you agree that visibility is so important, does NETSCOUT provide you with the right level of visibility? And again, the vast majority agree that NETSCOUT delivers the visibility required to succeed. So with that, what you see here are some specific customer testimonials from customers such as Quicken Loans, Defcom, Express Scripts, First Energy, and Court of Appeals. And you can see they all kind of agree that NETSCOUT visibility helps them with the bottom line, reduce mean time to knowledge, etc. Now, Ray, you interface with customers almost on a daily basis, right? So would you provide us with some testimonials based on your customer experience?
Yeah, okay, yeah, I could be here all day, but haven't got time all day. Anyway, a couple of ones that I hadn't thought was in these complex environments, whether it's multi-cloud, in the example that I gave you, we had a customer, he had users complaining about their Citrix service, as an example. The reason why they were complaining about the Citrix service was because that's what the users were logging in. So Citrix is slow today, okay. But it turns out, of course, that's not very helpful because 9 times out of 10, it's not Citrix, it's something else. So if you think about Citrix, maybe it's a front end to the service, and there's a whole lot of back end stuff going on. It's database servers, web servers, app servers, and those sort of things at the back end. We've got that visibility across all those domains, and in this particular example, it wasn't Citrix that was a problem. It wasn't AWS that was the problem, so that's kind of good news. It turned out to be an app server that was actually causing, and it's part of that service chain, an app service which is delaying that transit of the traffic and therefore the application to the actual users themselves. So we were able to pinpoint that, and if you think about it, that's a pretty complicated thing to do, but if you remember our dashboard, we can actually segment this application into the front end VDI servers, the back end app servers and database servers, and any of those authentication servers. And the answer stared us in the face when we were looking at those dashboard tiles. So that was pretty useful for a complex sort of environment. Another example is kind of interesting. I worked with a customer recently deploying VPC traffic mirroring into their Amazon environment, and they'd migrated a lot of their workloads into the cloud, and they decided which applications were going to be active in the cloud and which were not. And so we plugged this all in, and we started discovering those interactions, discovering the traffic going on, and we saw an unusual one on an unusual port, as it happens. And then, that didn't mean anything to me, but when I drilled down to it, one of the IT guys says, hang on a second, that's an application that we decommissioned 6 months ago. It's no longer in use. The problem was it was embedded into the AMI of those app servers that were being spun up. The application was still active. The ports for that application were still open, representing a couple of things. Maybe a security problem, because there's an open port on that server that they forgot they left open, as it were, because it was an application that used to be live. But it also was generating redundant traffic into their infrastructure, which could potentially be a time bomb waiting to happen. So, you know, it's those sort of things, the discovery, that service triage that we have, that kind of make this technology really useful in these hybrid environments.
Very cool. So let's summarize our presentation today.
Yeah, so NETSCOUT Smart Data. So it's derived by packets, the single source of truth. They don't lie, and they are everywhere. They're everywhere where your applications are communicating, whether they be in AWS, in a colo, in the hybrid, or wherever. So if we tap into those, with smart data, we can get you some really useful metrics about performance and security insights into that sort of application. What we've done with vStream is make this practical and affordable, because packet analysis, if you're sifting through gigabytes of data, it's hard to do manually, and you've got to be a rocket science, which I'm not, to actually do this. But we take that away from that need away from you, because we're figuring out the error messages and what's embedded in those packets to give you those metrics for performance or errors and things like that. And that's what you use to actually detect what's going on, and then you can actually get back to the packets at the end to realize and provide the evidence if you need it to give to various things. So it's actionable intelligence, it's software, so it's affordable, and we can deploy it at scale into your AWS environment, as well as everywhere, colo, public cloud, private cloud, on-prem, and of course the packets, as I said, are the single source of truth that makes the single pane of glass a reality.
And we started the presentation by talking about digital transformation and how it impacts IT transformation, and cloud migration is one important component of this digital transformation. And the bottom line is that we demonstrated that NETSCOUT Visibility Without Borders facilitates the visibility you need to migrate to AWS with confidence, and gives you the common situational awareness that allows the IT organization to innovate effectively in a more agile fashion And the bottom line is it ensures the end user experience. So this is our story about how NETSCOUT Visibility Without Borders is enabling our customers and partners to migrate to AWS with confidence. Thank you very much.
Thank you.